So today's lesson is on rational functions. The essential question is super basic. What is a rational function? Let's define it. A rational function is a ratio. Remember, ratio is just a fraction of two polynomials. So we're gonna take a look at the parent function of a rational function, which looks like this. F of x equals 1 over x. F of x equals 1 over x. Okay, so remember that a parent function is the smallest possible rational function. So in this case, it's the smallest possible rational function, but remember, a parent function is just the smallest it can possibly be. So like the parent function for quadratics was x squared. For a rational function, it's 1 over x. Okay, so let's look at transformations. Now, transformations are going to be the same as they were for our quadratic functions. So remember a, h, and k? It does the exact same thing for a rational function. So to get from our parent function, our most basic function, to a transformed function, it's going to go from 1 over x to a over x minus h plus k. So let's review again. So that's a parent function, and that's the possible transformations. Let's review the rules again for a, h, and k. They're exactly the same as we used for quadratic. So recall, when you have the absolute value of a, that just means we're taking, if it's negative, it's going to be a positive. Okay, so like let's say up here, let's say this was a negative, and then we had this whole function here, and a, h, and k were actually numbers, and we had a negative here. That negative does something different. Remember that negative in front reflects, so it has nothing to do with this number a. So that's why we put absolute value. It just means if this a is a 2, if it's greater than 1, or if it's a negative 2, because the absolute value of a negative 2 is positive, right? So that 2, no matter if it's negative or positive, we're just looking at the actual number. If that's greater than 1, we're going to stretch by a factor of a. So whatever this number is, like if this was a 2, we'd stretch by a factor of 2. Okay? If it's less than 1, so if this was a fraction, 0.5, or like 1/2 or whatever, that's less than 1, we're going to compress by a factor of 1/2, or a. If a equals 1, we don't stretch or compress. It stays the same. So if this was 1 over x minus 2 or something, that 1 just means we don't stretch or compress. Now remember, this is what I was talking about. When a is a negative, if this is a negative number, if it's less than 0, we reflect over the x-axis. Okay? So if it was negative 2, that negative means we reflect. That 2 means we stretch. Okay. H. Translate graph left or right. That's what h does. If it's x minus h, nope, that's wrong. Okay, if it's x minus h, we're going to go right. Let's erase that. We're going to go right h units. Right h units. Remember, it's always the opposite. And then when we have x plus h, we're going left h units. So it's always the opposite. So here, for k though, it's not the opposite. K translates up or down. If you have a positive k, a positive number here, we're going to go up. And if we have a negative k, so if this is a negative k, we're going to go down that many units. Okay. Oh, and let me just make it clear one more time. Don't forget, I wrote that wrong. X minus h, you go right, and x plus h, you go left. Okay, so make sure you have that down. So let's look at some examples so we can kind of apply and see what the heck this all means. So our example says using f of x equals 1 over x. Remember, this is the parent function. So we're going to use the parent function as a guide. We're going to describe the transformations that's happening from this function. Okay, so from f of x equals 1 over x to this function, 1 over x minus 3, what's going on? Well, we see that minus 3, right? And if you look back up at your notes, what does minus 3 mean? X minus 3 means we're going to go right that many units. So it means it translates the graph right 3 units. If we have, so how is this function different from the parent function up here? Well, first of all, we have a negative. We also have a 2 on the top, and instead of just x, we have a x plus 5. So, first of all, we're going to translate the graph left 5 units. That's what this piece means down here. Okay. Now let's look at the 2. Stretch by a factor of 2, right? Because 2 is greater than 1. And remember that negative on the outside means reflection across the x-axis. Okay, number 3. F of x equals 2 over x minus 3. So what's going on from the parent function to this guy? Well, there's a 2 on top. That means we're going to stretch, right? The x, we're actually not going left or right. Look, the x is just, it doesn't have minus or a plus after it on the denominator here. So we're just going to say that it doesn't go left or right, but it does go -3 for k. So it's going to go down 3 units and stretch by a factor of 2. Okay, let's look at one more example here. F of x equals -1 over x plus 6 plus 2. What's going on from the parent function to here? We have a negative. That a is actually staying the same. We have a plus 6 on the bottom and a plus 2 out here. So, translates the graph left 6 units. Remember, it's always the opposite on the bottom. So left 6, up 2, and reflection over the x-axis because of that negative. Right there. Okay. So for a rational function in the form of f of x equals a over x minus h plus k, first of all, the graph is a hyperbola. You're going to see what a hyperbola looks like in a minute, but just know when it's in this form, that means a graph is a hyperbola. So remember when it was in the form of like something squared, x squared, right? X plus 3 squared, whatever it was. Remember it was in the shape of a parabola, so it could be, it's like a U or an upside down U, right? In this case though, it's a hyperbola. The vertical asymptote is at x equals h, and the domain, okay, this is just a fancy way of saying x such that x cannot equal h. That's the domain. The range is y such that y cannot equal k. And there's also a horizontal asymptote at y equals k. Okay. So let's practice this. We're going to state the transformations just like we did in the first 4 examples, but then we're going to look at the asymptotes. Now, an asymptote is just, it's a horizontal or a vertical line. In this case, we're not going to be looking any deeper than that. So horizontal or vertical line where that it cannot equal that number. So it actually looks like a dashed line on a graph. And maybe your graph looks like this. And maybe it can't go past here either. And then your graph looks like this. So you see how the graph's never going to reach those dashed lines, means it can't equal that number. So that's what an asymptote is. Domain and range, we've heard of that before, right? Domain is x, range is y. So let's look at this. So first of all, the transformations. You're familiar with the transformations. We just did that. So let's look at the transformations for this function. How is it different from the parent graph? So it goes left 2 units. Remember, plus 2 means left 2 units, and it goes up 4 units. So you got that down. That's the transformations. What about the asymptotes? So let's look back up here. It says the vertical asymptote is at x equals h. Where's h? H is down here, right? Notice it's the opposite. So it's at x equals h. Since oops, I did not mean to erase that, sorry. Since it's x plus 2, remember we're going left 2 units. So we're going to say that the vertical asymptote is at x equals -2 because we're going left. The vertical asymptote is at x equals -2 because we're going left. Okay, it's always the opposite of whatever you see here. So it looks like x plus 2, so we're going to go vertical asymptote at x equals -2. Now, it says up here that the horizontal asymptote is y equals k. Remember, k is this number, so our k in this case is 4. So our horizontal asymptote is at y equals 4. Domain, remember the domain was x such that x cannot equal h. Well, our h in this case is -2. So x such that x cannot equal -2, and our range is y such that y cannot equal -4. I'm sorry, +4. +4. It's just another way to write domain and range, so don't let that freak you out, okay? So here, number 2, f of x equals 1 over x minus 3 minus 5. So what is going on from here, from the parent function? We have a -3 on the bottom, which really means it's going right 3 units, and we have a -5, so down 5. Now let's talk about the asymptote. So here, the vertical asymptote is at x equals h. What's our h in this case? Our h is a right 3, so it's a +3. So our vertical asymptote is going to be at x equals 3. You always have to write x equals. A vertical asymptote is always up and down, remember? And a graph, when it's x equals 3, it's going to look straight up and down. It's going to be a vertical line. That's why it's called a vertical asymptote. So you need to write that x equals. Our horizontal asymptote is a horizontal line. So it's like the horizon. It goes from left to right. And that's always going to be y equals. Well, it's going to be y equals, since it's down 5, y equals -5. Now, our domain and range is going to match this. That's why I put them right next to each other, like over here. So notice that our domain is x such that x cannot equal -2. But x can equal any other number but -2. Range, y such that y cannot equal 4. But y can be any other number except for 4, because we have an asymptote here. Same thing here. X can be any other number but 3, so we're going to write it like this. X such that x cannot be 3. That's the only restriction. Okay, range is y such that y cannot equal -5. So the only restrictions is where, see how these match? That's supposed to happen like that. There's a reason for that. We're going to take a look at a couple graphs in a minute, and you're going to see how these graphs look. So f of x equals -5 over x minus 6 plus 3. There's 4 translations going on here. Right 6 units because of this guy down here. We're going up 3. We're also have x-axis reflection because of this negative. And this 5 is greater than 1, so we're going to stretch. Oh, I didn't write that. Okay. We're also going to stretch. Where can I even fit this? Stretch by a factor of 5. I'm just going to say stretch by 5 units because I don't have room. Okay. Now we're going to look at the asymptotes and domain and range. So our asymptote, our vertical asymptote is at x equals h. So x equals 6. Our h is a 6. How do we know that? Because we're going right 6 units. X minus 6 means we go right 6, which means it's at x equals 6 is the vertical asymptote. Our horizontal asymptote is y equals 3. How do we get y equals 3? This is k, up 3. Remember up here we said at y equals k. So our horizontal asymptote is at y equals 3, because our k is 3. Domain, x such that x cannot equal 6. And our horizontal asymptote, y such that y cannot equal 3. Notice how these numbers always go together.